Hello everyone, this is Abhay Sharma, and in this tutorial I am going to talk about conditions, comparison operators, identity operators, membership operators and logical operators. This tutorial is slightly longer than I expected, but it covers a lot of crucial concepts, so just relax and enjoy, and afterwards practice a lot. So first of all, I'll talk about basic concepts of conditionals. So there are 7 nodes in Boolean list, in which we have talked about these two nodes in earlier tutorials. This invert Boolean node is pretty simple. It just inverts the output. So if I connect it with this node and toggle the switch, you can see what it does. Okay, I'm gonna delete these nodes. Now let's talk about these two nodes, compare and switch. With the help of these two nodes, you will be able to compare some values and make a decision. And based on that decision, you can execute whatever you want. Honestly, I was a little bit confused about how I will explain these nodes in the best way possible, and finally, I have decided to go with Python scripting. Sounds strange and scary, but believe me, it's not. You know why? Because it's just plain English. Let me show you. I'm gonna create a script node, generate a script file, make some room here, and select our script file. So if something equals something, do this. Else, do that. Is it hard to understand? Except this equals operator which make any mathematician's brain explode. But actually it's just an equality operator, which is different from assignment operator. If you want to know more about these operators, ask me in the comments. But honestly, is it difficult to understand? I think it's not. This something equals something is a Boolean statement which results in a true or false value. And if it is true, it will execute this line. If it is false, then it will execute this line. What if you need more than two output statements? Well, you can use nested conditions. So let's say if I write else if, which is written elif in Python scripting, something equals something too, just imagine something else, and then do this too. And then I can copy and paste the same thing however many times I want. Let me show you a real example which will make more sense. So let's say I want to change the color of this cube based on some condition. So how do we change the color of the cube? Well, we can use this choose color node and a viewport color node. Let's connect it and select the default material. Now if I select any color, then the color of the cube will change. We can also use combine color node to do the same thing, except we have to enter numerical values. But what if the color of the cube will change if I write something like red? We can do this with conditionals. Let me show you how to do that. So we'll add a string input and a color output. I'm gonna rename this string to text. Let's write our script. So if text equals red, I want the color to be, I'm going to copy and paste the exact value in here. So 1.0 for red, 0.0 for blue, 0.0 for green, and 1.0 for alpha. Let's connect our output node to viewport color. Obviously we have to create it first. Make some room. Let's connect it. Nothing happens because we haven't written anything yet. Type red and the magic happens. So this is what will happen if the condition is true. What if it's false? What if the text fields are blank? Well, let's make it black. Now if I type anything other than red, it becomes black. So currently it's limited to only 2 outputs. What if I want more? Let's say I want to change the color to green or blue also. Now we can use nested conditions. So if text equals green, make the color green. Let's copy and paste and change the values. One more for blue. Let's test it. So that's how conditional basically works. I'm going to delete these nodes. So how these two node resembles to our script? If you look at the comparison node, it's using a Boolean equality operator, which looks like assignment operator, but it is actually an equality operator. And it's comparing two similar data type values, A and B. Like here we are comparing text to red, which are string data type values. After comparison, it results into true or false Boolean values. If it is true, this line of code executes. If it is false, then this line of code executes. So this comparison node compares the value and gives a Boolean result. Then we can use this switch node to decide which node or node tree to execute when it is true or false. Let's connect it. So this true field is similar to this line of code and false to this line of code. Now move these things out of the way and let's see types of operator that we're going to talk about quickly. There are 7 types of operators in which we aren't going to talk about assignment and bitwise operators in this tutorial. Arithmetic operators, I assume you already familiar with. Comparison operators, we'll see each element one by one. You can pause the video and take a look at these notations. Logical operators has 3 basic types: and, or, not. Identity operators has 2 types: is and is not. Membership operators also has 2 types: in and not in. Let's start with comparison operators. I have 2 cubes with same size and we're gonna see how we can use compare node to compare their scales and get a Boolean value. But first of all, there is a limitation with this particular version of animation nodes, and that is the input connection type of the compare node is not generic. Means it cannot accept any data input except floats and integers. You won't have this problem in the next version, that is 1.7, which is currently in development stage. You can still download it and use it. I have checked it and it works, but as I said, it's in development stage. Actually, I have asked about this issue to Jax Luke, the creator of animation nodes, and he told me to change the type in the nodes advanced settings. But by the time I have already recorded the tutorial. So if you want to change the type, then you can do it in advanced settings. Okay, let's import the transform information of these cubes and let's connect it. You can see it splits into its basic components, but it doesn't matter because it's going to work for us. We can compare the x scale of these cubes. So right now the output is true. Why? because both cubes have same scale in x-axis. Watch this output node. Currently it's true, but when I change the scale of this cube, output changes to false because now they are not equals in size. If I let go without confirming the scale, it goes back to true. Let's change the operator to not equals to and see what happens. The output says false. Why? Because both cubes have same scale. If I change the scale of any of the cube, it will become true. Basically, it is opposite of equality operator. Next we have less than operator, which means input A has to be smaller than input B in order to make the condition true. Let's make the cube A smaller than B. And you can see the output is true. So this cube's scale right now is 0.8. Let's make the cube B smaller than cube A. Once it goes below than 0.823, our condition output becomes false. Now to make the condition true again, we have to scale the cube A smaller than cube B. So that is the less than operator. Now both cubes have same scales, right? And the operator is set to less than and the output is false. Sometimes you may want to include this number in your true condition. So anything above zero point 0.6 will be false and anything starting and below from 0.6 will be true. For that you need to use less than and equals to operator. Now you can see both cubes have same scale but the output is true. If I make the cube larger, the condition becomes false. If I change the scale to 0.6, it becomes true. Next is greater than operator, which is just opposite of less than operator. You can also use the invert boolean node to get the same result, except it will invert the output when values are equal. Let's change it to greater than operator. Right now the output is false because the scales are equal. Let's make one of them bigger and the output changes to true. Next is greater than and equals to operator, opposite of less than and equals to operator. So now if I make the both cubes similar in x scale, then output is going to be true. Greater than 0.6 will be true and less than 0.6 will be false. So I think I have covered all the comparison operators. Let's move on to switch node and see how it works. As the name suggests, it routes the correct output based on the boolean result. Let me give you an example. So let's say I want to rotate one of the cube, but it will only rotate when the scaling of both cubes are same. So let's create an animate Euler node. Let's connect the boolean result to condition input, Euler result to true input. You can see the input adapts to the data type. I want to rotate in y-axis. Let's say a full spin of 50 frames and interpolation to cubic. I'm also going to change the timeline range to 50 frames. Don't forget to attach the time info node. Let's create a transform output node. Turn on rotation. Connect the output to rotation and choose any of the cube. Play the timeline or just press Alt plus A shortcut key. It starts to rotate because both cubes have same scale and the condition is true. If the condition is false, it won't rotate. So if I scale this cube, condition becomes false and it stops rotating. This is a very basic example, but I hope you get the idea. Okay, let's talk about identity operators. These operators are used to compare the memory location of two objects. So I'm going to create two compare nodes and let's set their operators to A is B and A equals B. Create a float input and connect it with A equals B node. It's going to be true because equality operator compares the values. Now let's connect it to the A is B node and the result depends on whether they have the same memory ID or not. In this case, it's not. To show their memory IDs, I have to create a simple custom node. So I'm gonna fast forward a little bit. Okay, let's see what is the memory ID of these float input nodes. Looks like it's changing all the time. If you pause the video, you can see they have different memory IDs. That's why the output is false. Let's check it with a different node. Let's create an integer node and connect it to A equals B node. The result is going to be true as expected. Let's connect it with A is B compare node. The result is true this time, which means they have same memory ID. Let's check it. See? Okay, there is another identity operator, is not, which is opposite of is operator, but you can use invert boolean to achieve the same result. Okay, let's talk about none operator, which is not an identity operator, but I don't know where to put it, so let's talk about it here. None operator is equivalent to null if you are familiar with other programming languages like C++. Basically, it means empty. For example, if I create an object input node in here, right now no object is assigned to it, so it's going to return none. If I assign any object, then it's going to return that object. So it's a state that you can compare. If I try to connect it with this node, it doesn't work because of its current limitations with this version. So let me create the same node with a generic input type quickly. So you can see if the object input is not empty, it results in false. If I clear the object, then it's true, means it's empty. Let me give you a slightly better example to use conditions. I'm going to create a spline object and one of the points in spline object is going to be activated when an empty object comes into a certain radius. So let's create a spline object first. Well, we have to activate it. Let's create two empties. Add one more vector input. Let's import their position. Connect it with the last point. Our spline object is drawn in the viewport. Now what I want is whenever this second empty object goes near to the spline in a certain radius, the spline should grab the position of this empty as one of its points. First of all, import its position. Next, we will compare the distance from the grid origin. We can get the possible nearest vector position, but for simplicity, we'll stick with grid origin. Let's compare the distance. So if it is inside 2 grid units radius, I forgot to change the comparison operator to less than, but eventually I will change it. Let's create a switch node. So if the condition is true, then grab the position of this empty object. If it is false, then it should be 0, 0, 0 in all axes. Connect it as second point. Now let's try to move it closer. Let's see what's the distance right now. Try again. Yes, it works. Let's change this to 5 units. You can do a lot of stuff with this. Just imagine. Okay, membership operators. Interesting operator, but it's not available in compare node list options because it deals with list members, and there is a node in animation node list menu, search element, which does the same thing with more efficiency. I have included this topic here because I think it's interesting. So basically, membership operators check whether a given object is a member of a list or a group or not. I haven't talked about loops and lists yet, but still, if you think about it, you can achieve the same functionality with basic node types without using this in operator, except you have to loop through each element and check its identity. But why should you do that if you already have this in operator or search element node? So here I have created few cubes and created an object list out of it, and I want to search for a particular cube to check if it is part of a special group so that I can execute something. In the script you can notice that I'm using in keyword to search for a particular object in the list A. If it's a member, then the result will be true, otherwise false. So let's connect list output to the list input. You can see green cube is a member of this list. That's why output is true. If I clear the green cube from the list, output changes to false. Alright, now let's talk about logical operators. Logical operators are used to combine two logical statements. This is pretty straightforward, nothing special. You have to practice a lot and remember what each operator means, because in the beginning it's going to be confusing. Basically, there is only three logical operators: and, or, not. But there are other variations as well. A and B means it's going to be true if both operands boolean A and boolean B is true, otherwise false. Not A and B operator is opposite of A and B operator. Means if both operands are true, it's going to be false, otherwise true. A or B operator means if both operands are true, then it's true. If any of the operand is true, then it is true. If both operands are false, then it's going to be false. Not A or B operator is opposite of A or B operator. Means if both operands are true, then it's false. If any of the operand is true, then it's false. If both operands are false, then it's going to be true. A XOR B operator is going to be true if only one operand is true, otherwise false. If you need to combine more than two logical statements at once, then you can use Boolean list logic. Pretty straightforward options. All true means all Boolean inputs needs to be true. All false needs all Boolean inputs to be false, and etc. And now I'm going to show you another example where I have used logical operators, but I'm not going to show you step-by-step process because it involves loops and that I haven't talked about yet, so I'll just walk you through the scene. So in this example, consider this white cube as a character and these blue cubes as reward points. If I move the character forward, you can see it's collecting reward points, sort of. You can download this file if you want to. I have included the link in the description. So I have created a list of blue cubes, then I am looping through each element and comparing the distance between white cube and each blue cube. Then I am checking if it is less than one grid unit. Then I used a OR logical operator to combine a different node tree which is doing the same thing except it's an empty object instead of white cube, and the checking distance is 7 grid units. After that, I'm using an object visibility output node to control the visibility of blue cubes. Alright guys, that's all for this tutorial. Thank you so much for watching. If you liked this tutorial, then give it a thumbs up, comment or share. Next tutorial is going to be on list probably. Until then, bye.